second part. On this part we will be thinking about how creating booleans with nodes work and what we can do with what we have so far. So we select our object, any object will do, go to shading, change to geometry nodes, and add a modifier, geometry nodes. Okay. Okay, so first, what we have here, it's this geometry. For example, we have a bunch of nodes to play with. We will start, for example, with the transform. This is more or less like changing this, but inside a node. If you move it, let me add what I'm doing here. Yeah. And okay, so if you move it in X, whatever, Z, you can also scale. And then we can, for example, we have a new node now that it's called join geometry, that it's very interesting because you can, for example, if I plug this here and I move this to, for example, 1, now I plug this here and I plug this to the output, you will see that we have the original shape, the original geometry, and another geometry because it's joining here, that it's moved on x-axis. This is practical to see what you're doing. Maybe if you plan to make a boolean, for example, it's easier to just place it like this. And then you add a boolean node. The second one is always the cutter. If you use, for example, difference, the first one will remain and the other one will be the cutter. The other one will be the cutter. So, for example, there. And so what else we can do? For example, we can add subdivision modifier. Change levels. We can change to shade smooth if you want. I found a way to add at the moment we don't have a way to modify, let's say, the vertex or edge individually, and we cannot, for example, if I want to keep like an edge there, the only way I found to add a loop cut is to use a boolean. So we take let's take the original with the subdivision. Let's take the original and one that is on the same spot first. And we will use union. I have on my mouse a link to activate the, I think it's this, yeah. So that way it's easier to see what's going on. And if we move this on the z-axis, for example, you will see that you get new edges there, and then when you use the subdivision, you can create different you can hold the bevels there. Of course, it's not practical at all, but for now it's the only way I found to do it. Another thing you can do is to add other objects to this setup. For example, if I create a monkey there, I will take it out of the way. We select this geometry, no, object info, and then we choose the Suzanne, and you can use it, for example, join geometry, you plug this one and this one, and now you can also affect the Suzanne. You can create Booleans between them or whatever. Okay, so let's make a quick and simple practical. This goes for my friends on Erindale's Discord server. We will be making a table. So first we add a transform, we plug this there, we create a Boolean, and we will change on y maybe 0.8 and difference, so we get this. Then we will also, using another transform, this time we will change this to 0.8 and take this one. We have the, let me think for a second. Okay, so to change the size of this, I want the original shape that then comes to this two to be affected. So when we scale the original cube, it will also scale the one that comes here and comes here. So I will transform it before, not here, but here. And take a look. So when I scale this up, this one scales and this one scales too. It's like when you use mapping also. So the problem we have here is that the origin point is in the middle, but I did it on purpose to play a bit with math instead of changing the origin point. So what we have to do is to expose these first, combine XYZ, change everything to 1 for now, and value, and we want to when this changes to 2, it means it's the double the size. We want to move the cube half that size up, if that makes any sense. But we have to take in account the dimensions of the object. So it's half of this that we need to, if the dimension is different, you have to take half of the set dimension. So when this is 1, we need the z to also, and this one it's the same. As you can see now, when we, in this case we want it to grow, no, it's okay, like this. So we can set the size of the table. But maybe I will just show you briefly what I said here. If we go outside this mess, let me that, and we scale this, let's say to 4 meters. Apply scale and activate this again. This is there, but check how it behaves differently. So now what we have to do is compensate this. Now it's 4 meters tall, so the movement in z must be 2 every time this moves 1. This changes the scale. We have to, so you multiply this, sorry, math, multiply by 2, multiply, that's why, multiply this by 2. Okay, so we have to multiply this by 2. That's a half of the z value. So when this grows, when this multiplies, this moves by half its size to compensate, and that's why you don't see it actually moving, it's just growing. Okay, we will leave it like this for now. Now we need the top. For that we will use the, let me think, we have this changing size up and down. We need the same but without the scale, just the translation. So we will do another transform. We plug this here and we will use the same the same translation, but the scale will remain the same because we don't want to scale like the thickness of the top part. And maybe we will scale it a bit in X and Y. We don't need to make a boolean here. We will do it manually with the scales. So we add in this case join geometry. We plug this one. We change the scale. And we will need to make a little change here because we will add this vector to the one we will use here. So vector math, and the problem here is that we need to compensate also because the movement compensates for the scale, but we need to compensate that scale also to have the top of the table at the same spot. So instead of adding this, just we will be multiplying this by 2. For example, if we multiply this by 2, we no longer need to move this because it's already moved by this multiply by 2. And when we change this, now it behaves as expected. So we have the table size there. Okay, and this way you can keep playing with everything. Maybe you can do the legs individually, so you can just display, move them instead of having to compensate for the scale or whatever. But yeah, that's it. And we will be creating something a bit more crazy to just have fun. Instead of finding a modifier, you can just click here, it will be added. We create first the simple shape. As I said before, this is for my friends in Erindale's Discord. We will create the basic shape for the table, this time super simple. Okay, so we have our shape, Ctrl G. Not what we wanted. Okay. Ctrl G. This is the shape. We will create a value here. This will grow as we make iterations, you will see. Now we add a transform here. We add a join geometry. So we will add what we have before. We will multiply the value here and add one here. I will explain a bit. We want to affect not random float. We will make this -1 to 1 and play to the rotation. That will rotate the three angles, the three vectors. And here we want to expose and move in Y. Value multiplied by, I don't know, 3 maybe. And join this here. And this here. Okay. this one also there. That way we will have only one value entering, not two. Same here to our group, and this will be our output. We will have two outputs. So we take this control group, we will plug this to okay, so a value of 1 enters here, gets multiplied and moves the new object there. Then also changes the seed to the rotation, and then we add 1 and we put it outside. That way now the value is 2. So if we add another group and we plug everything, it will have a 2 instead of 1. Then it will move. It will be moving 2 multiplied by 3 instead of 1. It will change the seed also to 2 instead of 1, and it will add another 1 and go back and so on. So now we have this. I will change this like this. So we have them at the same disposition. And now we add another one. We add the value, and since this one receives all that we had before and adds it to the same, it's like exponentially growing. So if we create around, I think it was like 20 iterations, that will make 1,048,000 and some tables. So we will do just that. So we have 2, 4, 8, 10, and 20. It will take a moment. And we have that cloud of super laggy tables, fractal, whatever. Let's see if we take one out. Okay, that's behaving better. As you can see, that's our light there. We have like a space cemetery of tables. Look at that. We made some sort of tree of tables. Okay, so that was not useful at all, but it's fun, at least for me. And we will be making other tutorials as soon as new releases or new updates come out. And thanks for watching, and see you in the next video.